So let's take a closer look at what makes Liquidmetal's material science so unique. Traditional metals crystallize as they solidify, forming grain boundaries. These are weak points in the material that reduce strength and increase the likelihood of corrosion and deformation. Liquidmetal's amorphous alloy technology is designed to frustrate crystallization, locking atoms into a disordered, glass-like structure. This random atomic structure means there are no grain boundaries. Without weak regions, Liquidmetal offers superior hardness, strength, and corrosion resistance compared to conventional metals. In contrast, conventional metals solidify with a crystalline structure, creating material fault lines that can deform under stress. At the core of Liquidmetal's formation is zirconium, a high-performance element known for its strength and corrosion resistance. And you'll notice it's non-ferrous, meaning it's completely free of iron, which can be prone to rust and oxidation. By eliminating crystallization and grain boundaries, Liquidmetal creates a material that combines the best properties of metals and plastics, which are durability, elasticity, and moldability, making it ideal for high-precision components across industries like medical, automotive, aerospace, and electronics. Okay, so let's get a bit technical now. When a molten metal cools, it seeks to transition from a higher energy, disordered liquid state to a lower energy, crystalline state. In conventional alloys, this transition is straightforward because the atoms can easily rearrange into ordered crystalline lattices. However, Liquidmetal is designed to bypass this energy minimizing process. Liquidmetal does not form grain boundaries because of the way the atoms are arranged. In regular metals, atoms are all about the same size, so they can easily stack into a neat, repeating pattern called a crystalline structure. When crystals grow and meet, they create grain boundaries, like seams where different patterns meet. With Liquidmetal, the atoms are different sizes, which means it's hard for them to line up easily. Instead of forming a crystalline structure, the atoms pack together in a messy, disorganized way, like fitting mismatched puzzle pieces into a box. Because there's no organized patterns, there are no grain boundaries. Liquidmetal does not form grain boundaries because their differently sized atoms can't stack neatly, so they stay in this random grain-free structure. All this results in Liquidmetal behaving more like glass, with properties as being very strong, elastic, corrosion resistant, and it can be molded with high precision, all without the weakness of conventional materials. Just one more thing. If you want to learn more about Liquidmetal and amorphous metals, visit our website and download the Liquidmetal Design Guide. We've been told many times that it's one of the best and most useful sources on what are amorphous metals, the molding process, material properties, design criteria, and post-processing options. It's just right there. Just fill in your information and click and you'll immediately get it.